Welcome to our webinar. I'm Ron Lucier, your host here. I'm an ASNT NDT Level 3 at the FLIR Infrared Training Center in Hudson, New Hampshire. And I'm here to talk today about the United States Environmental Protection Agency Appendix K rule, which has been recently issued. What is Appendix K? EPA issued a supplemental proposal on 11/8/22, which amended the originally published proposal. So they had published one during the summer, and they went ahead and readdressed some issues that were brought up in the public comments. Some major topics in the regulation are the performance of infrared cameras, training of personnel, developing operating envelopes of surveys, developing monitoring plans, and of course, record keeping. Where does this Appendix K apply? It applies to gas processing plants only. And here's a direct quote from the EPA. The scope, the specific component focus for the surveys is determined by the referencing subpart, end quote. The only reference subpart is natural gas processing plants. All other parts of the oil and gas supply chain are covered by 40 CFR 60.5397B, Quad O-A and Quad O-C. We'll talk about both of those a little bit later. And it's likely that this regulation will eventually apply to chemical and petroleum plants in the future, basically everybody who produces volatile organic compounds. Now, the EPA had significant concerns. There's a long history of optical gas imaging. The first commercial cameras were available in the year 2005, as was the training. I was fortunate enough to be able to write and present the very first optical gas imaging course for industry. And since then, the cameras have changed considerably. There are more camera manufacturers out there. There's excellent performance, a range of features. But the EPA is concerned to make sure that every camera manufacturer can meet the conditions for successful operation. So they define how the camera shall perform. We'll talk about that later. They're also very concerned about OGI camera operators. And this comes into the qualification of an operator. So they're going to mandate a performance audit frequency, and that shall be quarterly to verify that the inspectors remain qualified. Also, OGI monitoring requirements, specifying a dwell time to account for scene complexity. Now, what is a dwell time? That is the amount of time that you look at a component at a given angle. And so they're concerned that some inspectors are inspecting too quickly and missing leaks, particularly small leaks. So they're mandating certain requirements that the inspector must meet in order to assure that all the leaks have been detected. Also, the length of the survey period. The EPA is concerned that, given the above, inspectors may get fatigued and miss leaks or components. So they're going to be limiting the amount of time that an individual inspector can inspect without taking a rest break. Also, they're maintaining that the operator must assure that there's a delta T of at least 5 degrees Celsius, which is 9 degrees Fahrenheit, between the background, the area behind the gas, and the gas itself. So the gas will be assumed at local ambient temperature. So all of these are significant concerns and are addressed in the Appendix K. Now, the first one we want to talk about here is OGI camera performance. And I have some direct quotes here that many of the direct quotes are highlighted in blue here. So 1.2 scope, this protocol covers surveys of process equipment using OGI cameras in sectors where the majority of compounds in the emission streams have a response factor of at least 0.25 when compared to the response factor of propane, and can be imaged by the equipment must be capable of detecting or producing a detectable image of. Now, what is a response factor? A response factor can be used to characterize the relative sensitivity of one compound versus another for the same measurement instrument. And that goes way beyond optical gas imaging. The calculation and use of response factors provides an understanding of which gases can be imaged and those which cannot. In general, using a response factor of less than 0.25 makes imaging that particular gas very difficult to impossible. And all response factors are calculated relative to propane, which has an RF of 1. Now, if you go to the nice folks at providencephotonics.com, you can download the response factor chart. They did a tremendous amount of engineering and research, and they have several papers that are published on this. So you can learn which of the 500 or so compounds that they have on their chart will be successfully imaged with a mid-wave optical gas imaging camera. So that's the particular gases. Now, what they need to do is, or want to do, is they want each optical gas imaging camera meeting the following specifications. So they say this is required. So any camera manufacturer must meet these requirements. Now, this testing can be performed by the owner, by the operator, the camera manufacturer, or a third party. So they leave this open to individuals creating their own, individual companies creating their own lab facilities and verifying that the cameras can see methane emissions of 17 grams per hour or less, and either butane emissions of 5 grams per hour or propane of 18 grams per hour. And this has to be done at a viewing distance of 2 meters and a delta T of 5 degrees Celsius, which again is 9 degrees Fahrenheit temperature change, in an environment of calm wind conditions around 1 meter per second or less. And so these are the general testing requirements. Now, this is a departure from the previous Quad OA rule. In Quad OA, and in the greenhouse gas rule as well, the EPA mentioned a requirement for camera manufacturers to be able to detect a 50-50 mixture of methane and propane diluted to 10,000 parts per million, which is 1% by volume. So when the testing was originally done by the camera manufacturers, 99% of the leak was nitrogen, which the cameras cannot see, and 1% was that 50-50 mixture of methane and propane. And all the camera manufacturers are able to do this. Now, changing this makes a lot of sense, as the product and pipelines are not typically diluted. There would be no financial benefit for a manufacturer to go ahead and dilute their natural gas. That would require 100 times the flow to deliver to our customers. So this makes a lot of sense. Now, there are several international laboratories available for independent verification, but it's the responsibility of the manufacturer and the owner and the operator to provide accurate information to the EPA if requested. Now, another thing that they address here is camera calibration and maintenance. The optical gas imaging cameras do not need to measure temperature accurately. What we see here on the right is a calibration room, a FLIR calibration room, and those are for temperature measuring cameras. So in paragraph 7.1 of Appendix K, it says the camera does not require routine calibration for the purpose of gas detection. That's true. But may require calibration if it is used for thermography, such as with delta T features. Operators should follow manufacturer recommendations regarding maintenance and calibration as appropriate. Now, that is a bit contradictory. The EPA states that there should be an adequate delta T for testing and field inspection, yet states the camera does not require calibration. Now, calibration is a misunderstood term. Users can temperature calibrate their own cameras, provided they have an accurate temperature reference, which, as you saw in the previous slide, is a series of black body sources rather. Okay, if the camera is out of calibration, the user cannot adjust that camera. Only the manufacturers have that capability, but there's nothing preventing an individual user from verifying that their cameras can accurately measure temperature. Now, would the delta T be different if the camera was out of calibration and needing adjustment? Well, we can't say for certain. That really depends on the temperature calculation algorithm and the calibration function. But in general, the cameras don't go out of calibration by a small amount. It's usually a large amount. And testing that we have done, if even with a camera out of calibration, you're still able to verify that there is an adequate background. Now, again, the camera does not require routine calibration. and it's really up to the manufacturer. In the case of FLIR, section 3.3 in the optical gas imaging camera manuals, it says gas detection, no recalibration recommendation. In other words, we're not recommending that you have your camera temperature calibrated. And that is due to the ability to detect gases is not influenced by the calibration, will not degrade over time. And if you're going to be using these cameras for additional electrical mechanical scans, we do recommend annual calibration, and that is applicable to every single radiometric. Radiometric means that we can measure temperature. So bottom line on calibration is if you have a camera, you should refer to the manufacturer. That's what EPA says to see whether you need to have your camera calibrated periodically. Now, they address camera operators themselves, the performance of the operators, the qualification of the operators. And there are three training requirements for an operator. The initial classroom training, outdoor field training, so on actual sites, and refresher training. And so there's a heavy emphasis here to make sure that everybody is up to date with the equipment, up to date with their training. And that is, there's some pretty extensive regulations here. Now, the Appendix K places increased emphasis on the training and competence of the OGI cameras. And here's another direct quote. The facility or company performing the OGI surveys must have a training plan which ensures and monitors the proficiency of the camera operators. Training should include classroom instruction and field training on the OGI camera and any external devices. All monitoring techniques, best practices, process knowledge, and other regulatory requirements related to leak detection, so they are relevant to the facility's OGI monitoring efforts. In other words, you should get annual training to make sure that, or initial training to make sure that you really understand the process equipment that's out there, whether it's a compressor, a well, a separator, where you could expect to see gas and where gas shouldn't be expected. And if the facility does not perform its own OGI monitoring, the facility must ensure that the training plan for the company performing the OGI surveys adheres to this requirement. So this is not only for people who have their own OGI programs, this is for folks who hire consultants in. So the consultants performing these surveys must assure to the people who hired them that their training plan makes this and their inspectors are qualified. Now, the camera operator must complete the training before performing the monitoring surveys. Now, classroom training can be at a physical location or online, and has to include all of these topics here. This is just a short list. There are many other concepts here that should be added in training. The fundamental concepts of camera operation. Why and how does the camera detect a gas? Parameters that can affect image detection. Wind, temperature, distance, snow, rain. Description of the components and some sample imagery. For example, here's an image of a gas leak on a compressor, and here's an image of a leak on a well, and here's one on a separator. All these types of components, the more images that you see in your initial training, the better you are training yourself to look for detection. And also camera operating and maintenance instruction. How do we operate a specific camera, and what do we do for maintenance? Daily cleaning, daily inspections, annual trip back to the manufacturer, whatever is available. Okay, and also some procedures for performing the survey. They still require a daily verification check. But they've simplified it. I've covered this in another webinar at some point, but basically, if your camera turns on, produces an image, and you can image like a butane lighter or a sample station, you're verifying that the camera has the ability to detect gas that day. Okay, and they're still requiring this. So every day you're supposed to perform a daily verification check, and they give you some latitude on that, of course. Now, procedures for performing the inspection, you just have to understand this, again, this dwell time and the dwell angles, the inspection angles, at what direction we look at, with a caveat here that you don't need to go downwind of a leak to verify it. And again, with safety being the #1 priority for operators, look upwind, slightly crosswind, or maybe but slightly downwind, but completely avoid being in the plume of the gas for obvious reasons. And also to assure that all components are inspected. So given a facility, what's the entirety of the list of components, verify that you've inspected it. And as we'll see here, verify that the inspectors had the appropriate rest breaks. Also part of classroom training would be record keeping. You know, how do you keep your records? How do you store your videos? How do you verify individual components? How do you prove that you were there and you actually performed the inspection? And also some common mistakes. And one of the bigger common mistakes is seeing heat waves coming off the surface of a hot pipe or hot compressor. And just recognizing that that is a convection pattern and not reporting that as a leak. Leaks will come from joints, they will come from mechanical connections. But if you get really, really hot components to look at, these cameras are so sensitive that you do see the heat waves coming off that particular component. And also regulatory requirements. What are the daily, what are the local regulatory requirements, as well as the EPA. So the OGI cameras must attend an annual biennial every 2-year classroom training refresher. This refresher can be shorter in duration than the initial classroom training, but must cover all the salient points necessary to operate the camera, monitoring plans, best practices, maybe even a rewind of what did we find in the past couple of years and what did we learn in the past couple of years. Now, the EPA does not mandate how long this training could be, just that the individual person has to take it, every operator. So the refresher training can be at a physical location or it can be online. And there are extensive requirements for field training, and this is where there's been a big deviation from the prior greenhouse gas Quad A rules. Field training will require a senior camera operator. And a senior camera operator is defined as somebody who has conducted OGI surveys for a minimum of 1,400 hours over the entirety of their career. Now, if you're doing this on a day-to-day basis, on a daily basis, certainly there are many folks out there that would qualify as a senior camera operator. Now, that also has to include at least 40 hours in the past 12 months, and they have completed or developed a classroom operator training as defined in Section 2. And in, the hours spent by these camera operators performing comparative monitoring. So this is where the field training comes in. So the senior OGI camera operator, either as part of their initial training, retraining, or auditing of other camera operators, can be included. So that's, so if you're spending 40 hours a quarter training or verifying other folks, that counts, okay? And so again, this is a summary of just some of the field experience here. Now, there are provisions for current OGI operators with previous experience. And if you have had any sort of training course in the past, you are grandfathered in for that classroom training, but again, this is good for 2 years. Now, the field training still needs to be required, is still required, and it can be done via initial field requirements or the retraining, depending on your experience. No biennial classroom training is required if the classroom was taken 2 years before Appendix K is finalized. So here's, again, another grandfather scenario. And inactive operators can retrain in lieu of the initial training. So if you performed OGI and then you stop and you're getting back into performing OGI, you can just do the retraining rather than taking an entire course again. Now, the initial field training, that is a minimum of 3 survey hours with OGI where the trainees observe the techniques and methods of a senior camera operator. A minimum of 12 hours where the trainee performs the initial survey. So the first part is you're an observer. The second part is you're being observed by a senior camera operator. And the third part, a minimum of 15 survey hours where you go out and perform the inspection independent of a senior camera operator, and they review your work. Okay, so this will, in EPA hopes will make sure that the absolute best, most highly trained and competent inspectors will be out there. Now, there should be a final monitoring survey test of at least 2 hours, and a senior OGI camera operator follows behind. And so, as part of the field training, what this says is basically go out, you do a 2 hour survey, and a senior OGI person follows right behind you at some point. And if there are 10 or more leaks identified by the senior OGI operator, you should be able to detect at least 90% of them. You can miss no more than 10%, 1 out of 10, okay? And it says here, missed persistent leaks. Now, these would be constant leaks, as opposed to the transient leaks, these little leaks that'll appear, they disappear, they appear, they disappear, based perhaps on the position of a valve, of a control valve. So they do recognize that. And if there are less than 10 leaks, you are required to find all of them. So if the senior OGI operator finds them, you are required of them. If you fail the final test, the test may be repeated. And after the senior OGI camera operator provides instruction and feedback on performance improvement. Now, performance audits, again, this is a deviation from Quad O-A and the greenhouse gas rule. All camera operators must occur on a quarterly basis with at least 1 month between 2 consecutive audits. So they're requiring a performance audit for everybody to make sure that you are following all the procedures, okay? And they must be conducted according to one of the following procedures, either a comparative monitoring, and that's, again, like your initial field training, and that's near real time. It's where the senior camera operator follows behind and makes sure that you found all of the leaks. Or a video review. The camera operator being audited must submit unedited and uncut video footage of their OGI survey technique for review. And so again, quarterly audits for everybody. If the camera operator does not achieve the detailed benchmarks, then you have to go ahead and be retrained. Now, the comparative monitoring, a senior OGI operator will conduct a survey of at least 2 hours in the same area to ensure that no persistent leaks were missed. And again, it's the a 10% leak or less than 10, you have to find them all. In the video review, again, this is a 2 hour video of a survey. Multiple monitoring surveys may be submitted. So you go to one location, you're there for 20 minutes. You go to another, you're there for 30 minutes. So you have to submit, up to at least a 2 hour period of your recording. So you arrive at the site, you have a fresh SD card in your camera, start recording, do your whole survey, and as long as you have 2 hours, you can submit that to the senior OGI camera operator, and they will verify that you didn't miss anything, okay? And again, if you don't achieve this benchmark, then you're back and you have to be retrained as outlined in section 10.4.3 of the regulation. So if an OGI operator requires retraining in 2 consecutive quarterly audits, you got to go back back to square one, okay? And so this is very, very important that everybody perform up to the requirements that are here. And if you do audit, if you do fail an audit, you have to have a discussion for the reasons for the failure. You didn't account for the wind, you were there at the wrong time of day, you were looking at the wrong components, and then they're going to require a minimum of 8 survey hours where you perform the initial OGI survey with a senior OGI operator, and that's more or less mentor training, okay? And so this goes into details, but you can see here the idea that the EPA has is to make sure that you are adequately trained and you do a quality job. So also, if you haven't conducted a monitoring survey in over 12 months, then the operator has to complete the retraining requirements prior to conducting surveys. So life happens and you go, you're off the job for a month or a year or so. Then you come back. You've got to go back to the retraining requirements. And if you've not conducted a monitoring survey in over 24 months, you have to complete the biennial classroom training, that training that happens every 2 years prior to conducting the surveys. Okay, so make sure you refresh yourself. Now, there are grandfather operations, previous experience operators. So folks who've been doing this, like myself, for the past 18 years, um, the OGI camera operators of previous classroom training that included a majority of the elements listed in the section do not need to complete the initial classroom training as described. And again, the final rule date, believe, was in early December of this year, but there's still some question as to whether that's the final rule. So again, if you've been doing this for a while, you can skip the initial training, but you cannot skip that biennial training. Everybody has to go through that training every 2 years. And OGI camera operators who have 40 hours of experience over the 12 calendar months may substitute the retraining requirements, including the final monitoring survey test, for the initial field training request. So even those folks who have do this on a part-time basis, let's say, you're working 1 week out of the whole year doing this, you still have to complete the training, but it's not as onerous as starting from the start. The training rules here are very new, they're very detailed, and the employer of the camera operators have the final responsibility for certifying you. And so it is up to whoever either employs you or hires you to make sure that you meet these requirements. Now, the American Society for Non-Destructive Testing, and it's ASNT.org, has a generic written practice for non-destructive test inspectors. It's called ASNT SNT-TC-1A, and that is a great starting point for many firms and individuals. This is a written practice. A written practice is the document used by an employer to certify their inspectors. Now, that document, TC1A, is for all non-destructive test techniques: radiography, ultrasonics, acoustic emission, visual testing, so on and so forth, including thermal infrared, okay? And they don't specifically address optical gas imaging, but it is a great way to say, I am going to structure my company and qualify my people this way, and we incorporate the EPA. And it's a very, very straightforward process to take the information from there, customize it to your individual needs, and have your management sign off and say, here is our certification document. And just as a side note, if you are operating under a written practice and someone says, what makes you certified? And you say, I'm certified to my company's written practice, which meets SNT TC1A, which is, by the way, recognized worldwide as probably the best way to qualify people, okay? And however, as highlighted above, there's going to be extensive training for every single operator that's out there, and record keeping. Okay, so this is a huge step. Some think it's a burden, but at the end of the day, the whole idea is to reduce the amount of fugitive emissions as much as possible. So, but this will be quite the burden. Now, the monitoring requirements, the inspection that you have to do. Okay. The EPA is requiring an operating envelope. It's got to be established for field use of the OGI camera for all potential configurations, okay? And it can be established by the camera manufacturer. And they can say, as we'll see here, the camera operates in such and such a conditions under such and such a wind speed. And creating an envelope here really says we're not going to image when the conditions are outside of that envelope. In other words, let's say it's snowing outside. You're in the middle of a blizzard in the Midwest. That's probably not the best time to be out doing a survey, just because of the moving of the snowflakes and the high wind and the conditions. So that would be an example of an operating envelope, okay? And it must be confirmed for all potential configurations, such as the high sensitivity mode. So high sensitivity mode enhances our ability to visualize cloud motion, and cloud motion caused by a fugitive emission. If you have more than one lens, if you have a telephoto lens, if you have a wide angle lens, you have to have a operating envelope for that. And also, many people prefer to have their cameras handheld. Others like to have put their camera on a tripod, which, by the way, is very helpful for finding the really smallest leaks, okay? The very, very small leaks, a tripod. Again, you have to have separate operating envelopes for different configurations. And maybe, there may be other considerations that are here that you'll think about. Aerial or SUAS configurations if you're using a drone, fixed mounted inspection. So there's got to be a separate operating envelope for each and every one of those. And there is no statement that prevents an end user from establishing their own operating envelope. And this is what FLIR did quite a few years ago. This goes back into the original greenhouse gas rule. And this data was done from done at the National Physical Laboratory in the United Kingdom. And this is for a low delta T, so they're talking less than 4.5 degrees Celsius between air temperature and the background. And the numbers are there, 327, 104, 342, 120. Those are individual test numbers. Now, if it is green here, it meant that the camera was able to see that leak. And again, if you look up on the top there, that was the initial greenhouse gas rule, 60 grams per hour of a 50-50 mixture of 1% diluted methane and propane, okay? And so again, we're talking about a very, very, very dilute gas. Now, looking at full mole gas coming out of the pipeline, I personally think that you'd be able to see better. But here, this is the best published data that we have. And really what this says is that if you are, say, 20 meters away from a target, which is quite a distance, that's 66 feet there, in under a 5 to 10 mile per hour wind, you can still image that little teeny tiny gas. But if the wind is between 10 and 15, you can't. Okay, and so that's green. Green means you're good to go, and you can see here at 2.5 feet, even under high wind speed, or 2.5 meters under high wind speed conditions, you're good to go to inspect as long as it's safe to do so. Now, if you go to FLIR.com/instruments/optical-imaging, you can find the National Physical Laboratory report. It has much more data in there than this, but this is just an example of an operating envelope. But again, depending on your location, if you're in a hot location, if you're typically in a cold location, you can develop your own operating envelope. There are requirements in the docket that says you have to have such and such a temperature difference and wind created by a fan or some sort of mechanical motion to create this envelope. But those are the details that are only applicable to someone who is going to generate their envelope. Okay, and so development of the operating envelope is performed using the test gas composition, flow rate, and orifice diameter described previously, and it has to include several variables: the delta T, the viewing distance from the component, and the wind speed. Okay, so that is the basics, but there are quite a bit more conditions that you can evaluate. Now, the burden of developing a generic operating envelope will likely be the responsibility of the camera manufacturers, but that might not cover every single envelope, okay? One item that's missing from the EPA operating envelope is the difference between night and day, difference between a cloudy day and a sunny day. We need some of that energy in the back. So this is something that I think manufacturers can't account for all of this, but the individual owners and operators should. And also, if you're in an area that gets a lot of snow or gets a lot of rain, I believe that you should include the limitations for your operators there. Now, the OGI surveys, how do we conduct those? The monitoring plan must include a description of a daily verification check to perform prior to imaging to confirm the camera is operating properly. So here, this is going to be in your procedures: confirm that the camera software loads successfully, confirm that the camera focuses properly, confirm that the camera produces a live infrared image, and confirm that the camera can perform the delta T check function as expected. If this function will be used to meet the requirements. Now, some cameras have a delta T function built into them and others don't. So this applies to those particular cameras. And ensuring field conditions. Determine the appropriate wind speed and distance. We obviously covered this. Make sure you have an adequate delta T. On a personal note, I think that 5°C delta T is way too big. In our training, we tell people 2°C delta T, and they have no problem imaging the gas. But that's EPA, okay? And dealing with the interferences, fog, solar glint, hot backgrounds. These are conditions that you will encounter in the field. And also to ensure that all components are monitored. This is an example of GPS tracing, and it can be turned on in your many cameras. You enable this, and every 10 seconds or 1 minute or some other interval, it's going to record your GPS location. And there's free online software that can be used to trace out exactly where you were. The other thing you can do is to establish a route map. Now that would be burdensome for, if you have 1,200 wells to take a look at, to have 1,200 route maps. But again, that may be an option for some cameras or some facilities. And again, the GPS tracing and tracking is a wonderful technique. Now, the dwell time, very important, and EPA places a lot of importance on this, means the time required to survey a scene in order to provide adequate probability of leak detection. The dwell time is the active time the operator is looking for potential leaks and does not begin until the scene is in focus and nice and steady. Now, the initial EPA rule that came out said 5 seconds per component. Well, that's quite a big time, and they have reduced that to 2 seconds per component. And there's a table to help you determine this. And this is solely per component, and field of view is multiplied by the number of components being inspected. So if you have 12 items to take a look at between valve packing and vents, etc., in one scene here, you've got to multiply that by 2 seconds per component and verify. And this is good practice. Sometimes it's easy to say, yeah, I don't see a leak, and other times it's a good idea to say that I stood there and I stared at this area for a long period of time and I did not see anything. Okay. And so again, an example, a subsection view with 5 components would need a dwell time of 10 seconds per angle. So they're talking about the dwell time and the dwell angle. How far, what sort of angle do you look at, provided that you don't get downwind, okay? And avoiding fatigue. If a camera operator should not survey continuous for a period of more than 30 minutes without taking a rest break. And this was a subject of a lot of public comments. But again, this is very time intensive. This is very, you have to concentrate a lot when you have an IR camera, looking, maintaining your safety, etc. So this can be, this can be a good thing, etc. So if the survey is continuous to more than 30 minutes, the operator must take a break of at least 5 minutes after every 30 minutes of surveying. So you go an hour and steady, you've got to take a 10-minute break. You go 2 hours, you got to take a 20-minute break, etc. Okay? And operators can complete tasks related to the monitoring survey, such as documentation during the 5-minute rest break. And so long as you're not actively imaging components. Eye fatigue is one of the big things, okay? Particularly if in a hot, dry area and your eyes are drying out. This is really what they're addressing here. It's a human factor. And so if continuous surveying is desired, 2 camera operators should be employed to make sure that one gets a chance for a rest. Now for documentation, the name of facility, date, approximate start and end times, that can be gathered by simply taking as many inspectors do, you take an initial video, you do a safety survey, and have the time and date right on your video. And so I got here, and this is what it looks like, and then you do all of your detailed inspection, and at the end of the survey you go, okay, here's what it looked like when I left. And so now you have your start and your end times for your survey. And if surveys are more than 4 hours, record the weather conditions every 2 hours, which can be, hey, it's nice and sunny and calm and 72 degrees, or you can gather data from a handheld portable weather instrument. It's up to you. And now documenting the fugitive emissions. If no emissions are found, no footage is required. And that is a really important statement. And that mirrors what EPA basically said in Quad A. If you meet all of the conditions for a gas leak and you do not see a gas leak, there isn't one there. Okay, and so as long as your camera's in focus and you got the delta T and you meet all the requirements there, you don't have to record it. Okay, so there's no need to go into a facility and do a start and end recording except to document your qualification, your quality assurance audit. However, if a leak is found, capture either a short video clip or a photograph. And if the leak is not immediately repaired, it has to be tagged with a date, time, location of leak, and identification of the component, or a full video of the monitoring survey must be recorded. So some folks opt to turn the camera on when they get into a site, and they don't shut it off until they're done imaging that section or imaging an individual component like a large compressor. Okay, so they give you a couple of options here, but many folks go out and they find a small leak and they repair it. And it says here, if the leak is not immediately repaired, it must be tagged. Okay, so you have to document the leak and then you repair it. But once it's been repaired, unless you have something internal, you do not have to tag it. Okay. So the quality assurance video for each OGI operator, at least once each monitoring day, a minimum of 5 minutes long, to document the procedure the operator uses to survey, the dwell times, the angles, the distances, the background. And you can use one of we're looking for fugitive emissions to make sure the video is at least 5 minutes, and you do it once a day. Okay, I would say do it again if the weather conditions change significantly, like you went from bright sun to now it's lightly raining. Okay, and your monitoring plan must describe the process that would be used to ensure the validity of the monitoring data. So you've got to have sign-offs, you've got to have periodic comparative monitoring using a different camera operator or other due diligence procedures. You do the work and then you hire in a consultant firm and they come in and they verify what you found. Record keeping. Records have to be kept for 5 years in hard copy or electronic form. And everybody seems to be storing everything in electronic forms these days. The cloud storage is relatively inexpensive. And the facility must maintain the following records in a manner that is easily accessible to all OGI camera operators. And again, they have to be performed, these records must be retained for as long as the site performs OGI surveys. And, again, so that's above and beyond 5 years. And you've got to have the complete site monitoring plan with all the elements and the OGI camera operating limitations, plus all the results. Okay. And all data supporting the camera specification, confirmation, and development of the operating envelope. This is important to make sure that everything is documented. This is how we develop our operating envelope. This is how we are meeting it. Okay. And this is you ensure that the camera specification, whatever the manufacturer says the camera is doing, basically, you have to ensure easy access to these records and make the records available for review by the EPA administrator. And the training plan. This is going to be, again, quite burdensome because every owner operator must ensure that the plan for the company performing the OGI surveys adheres to the requirements of Appendix K, and to make sure that everybody that is performing those meet Appendix K as well. Okay, and again, you have to have your plan available if requested by the EPA, and make sure everybody has easy access to the plan. And training plan per operator. Okay, it would be a good idea to record and copy and store in several different places your own training records. Okay, when you were trained, what the subject matter was, etc. Again, the same requirements as the previous one. And these records have to include the date of completion of the initial classroom training, the date of the past final site survey test, that's the field training test by the senior camera operator, number and date of all the surveys performed, whether they were training or you're really doing it for your regular line of work. Date and results of the quarterly performance audits, date of the biennial classroom training, and documentation to support previous user experience, okay? And so there's a lot of record keeping that's involved here. The surveys, again for record keeping, you need to do a daily verification check, okay? Make sure your camera is still imaging gas. Identification of the site surveyed and the survey date and start and end times, camera operator, weather conditions, video footage of the photograph or any leak detected, daily QA verification videos, and the GPS coordinates for the route taken, or at least the GPS coordinates of the site. Okay. Again, what they're talking about for the route taken, that would be using that GPS tracing, which is available in many infrared cameras. Camera records, maintain calibration records. If you are going to calibrate your camera for temperature, identify that. If the facility does not perform its OGI monitoring, the owner or operator must be able to easily access all the records and make them available. So if you are hiring a consultant to have your optical gas imaging survey done, they have to provide you with the camera records, the training records of all the individuals if the EPA requires it. Okay. Just a short summary here. That's pretty much the webinar here. I just want to say a couple of words. The EPA is attempting to introduce practical quality assurance, quality control procedures to make sure that the maximum fugitive emissions are being reduced. That is the goal of this, okay? We all have to breathe the air. There's no incentive for a producer to leak gas. And so to me, this is a win-win for everybody. However, there's a real added burden here. There's a lot of burdens here, particularly with the training and record keeping, and getting your folks up to speed and making sure everything is documented. Matter of fact, if those who are familiar with the commercial nuclear power industry, pretty much everything that the EPA is adding into Appendix K here as requirements are normal everyday practice for the nuclear power industry. The documentation of people's qualification, the continuous training, the QA, QC audits, it's all there. And optical gas imaging as a technology, it's still in its infancy, okay? Again, 2005 is the first practical commercial camera, and today is 2023, so that's 18 years. You know, the technology is changing, the different types of cameras that are out there and different inspection technologies, they're all changing, and the regulations will change as well. And both are likely to continue rather. So anyway, that's our webinar. Thank you for your attention. I'm Ron Lucier, and here's my contact information. I would be happy to spend some time talking by email. If we had to do a quick Zoom, I'd be happy to do that. But it's been my pleasure, and thank you for attending our webinar today.